Okay, thank you. Thanks a lot. Good morning, everybody, and special thanks to Stelios for giving me such leeway in what to actually discuss today, and also to the two previous speakers who really introduced the topic. So today I'll be discussing the validation of the lesser-known aerosol layer height product, which we get from the satellites. To put everybody in the mood, here we have the first indication that there is aerosol in an atmosphere, which is always there, but it's good to know what it is. So we've already discussed this to know what the species are. So smoke in the purples, dust in the oranges, and this is the VERS instrument. Just a few days ago, you see our atmosphere is basically laden with the stuff. Then if we move to the aerosol optical depth, which results from this first indication that there is aerosol in the sky, you can already note there in the Saharan dust plume, which is indicated, how the 1.5 hours difference between one orbit and the next of these polar orbiting satellites really loses the continuation of the plume. Of course, that's not the case in the Canadian wildfires. They're in the north. They've been ranging nearly 20 weeks now, and they're still going on. I could not but already show the first, devastation we've suffered in Greece, the fires there in Alexandroupolis, the forest fires. So on the 22nd of August, another satellite product, the Aerosol Index, showed how the plume from the northeast of the country, crossed the Pindos mountain range, really rose high, and then filled the Ionian Sea with aerosols. If we look at the same picture, but now the optical depth, we see how it's far spreader than what the index indicates. And not only that, but the current algorithms that satellites use misidentified the thickest parts of this aerosol plume as clouds. These are these gray areas. It doesn't mean there was no observation. It means that the algorithm mistook it. It was so thick, so huge, and the next day spread everywhere, even further, south of Italy, Sicily, even reached the coast of Africa there in Tunis and Tripoli. What does this mean about the air quality in the region? Here we have the CAMS reanalysis for August. So Melanie really introduced the topic before. We have the PM10s only from the wildfires. Of course, watching her presentation, I realized that this might actually be even a best case scenario. Most likely we had even more PMs in the atmosphere, which we smoked through. And this is the reason why this aerosol layer height product that I want to talk to you today about is really, really important. Not only because the experts have said that it's important, but I hope to convince you as well. So we have these polar orbiting satellites. Already I've warmed you up with the nice images before, and today I will be discussing two of these, or the data from two of these, the GOMI-2, a long time series, METOP A, B, and C, and the TROPOMI Sentinel-5P instrument. These are in a polar orbit and nice width swath. Within a day, we see the whole globe. Up until last month, we had Calypso. Yes, it had a narrow path, but the wealth of information it provided on both clouds and aerosols is unprecedented, and really looking forward to the new instrument, hopefully soon to be in orbit. Of course, MODIS, again, you've already seen today, an amazing long time series with real nice information on the aerosol load and the two different VERS instruments currently in orbit. Now, this absorbing aerosol height is already an operational data set by EUMETSAT developed within the ACSAF project. It can be accessed freely to all those who are interested. The beginning of the algorithm first identifies that we have aerosol in the atmosphere. So we have this aerosol index. This is a map again of a few days ago, and you see how within a day the METOP C, the GOMI-2 instrument, can of course cover the entire planet. We see not only the Saharan dust, we see there the seasonal fires at South Africa, and of course the Canadian wildfires still going on. It's actually a shock. Now, for locations on the planet that this index is higher than a specified value, the aerosol the absorbing aerosol height product algorithm gets initialized and also produces an estimate on exactly where this plume is, more on the vertical structure, which is of course the interest in this topic in a tick. Now the Tropomi instrument, it's already in orbit and providing data for more than 5, maybe 6 years. They have their own aerosol layer height product, also operational, also accessible to all, and again, based on the premise that the signature in the near is so different if a pixel has aerosols and if it doesn't have aerosols. And I won't go, of course, into the algorithm details for you, but I will show you the validation efforts that we've been performing on this, also on this polar orbiting data set. We've been using the 2 LiDARs, the Spaceborne, Haliop, Calypso, an amazing instrument. I was just switched off last month, and among all the different features, vertical profiles, separation of cloud aerosols, what I really found interested, we as a team really found interested, is in that it can categorize the aerosols to a quite significant accuracy of degree. So we have the 10 different categories of aerosols, which are the audience so the
Please mute your microphone sulla. Thank you.
Well, I hope the clock stopped counting, right? I won't be penalized for this. Thank you, Yorgo. Can we go to more here and hide? It says hide floating. Oops, yes, that thingy there. Yeah, excellent. Thank you. Okay, so let's see. Oops. Okay, so where were we? Right. We were at what we used to validate the 2 previous satellite products that I briefly introduced, the Spaceborne LiDAR and the ground-based LiDAR. Like I said, the LiDARs, most of you know a lot more about it than I do. They measure and provide a number of different physical parameters as actually altitude resolved profiles, which are amazing for validating the new satellite products. It was mentioned already today that satellite products mature over time, and this whole process of validating is part of this maturity. So I'll begin with some severe dust and wildfire events. So in 2020, in October, Tropomi actually gave some really high values for the aerosol index. Remember, this is the first step in all these algorithms, identified that there is aerosol, and then the algorithm that actually produces where this aerosol is gets initialized. So here on the right, I hope you can see my pointer. Calypso, this is the narrow swath, this yellow little line, and here also in the same time actually show these 2 separated plume in the altitude. Now you might say, well, what are you on about? This clearly comes from the Sahara. This is why a validator has to always look at all the available data and indications of where these particles might come from. Of course, we looked at the DREAM model. We've seen already there was no dust, and lo and behold, the trajectory calculation by the high split model showed that these were indeed particles that came all the way from California. The California wildfires of 2020 reached the Mediterranean. They were measured by multiple LiDAR systems in the Mediterranean. In this case, I'm showing you the Potenza station. In the red box is the time collocation with Tropomi. And here we have the profiles. A clear two-plume structure is seen as by Calypso at two different altitudes, and once the LiDAR, the homogeneous LiDAR algorithm is run by the AeroNet database, we have a weighted, this red line, we have a weighted mean of how high the smoke particles are. Of course, they've traveled around the globe, they're already at more than 7-8 kilometers. However, the satellite product places them quite further below in the atmosphere. We, of course, have to look at dust. Dust is so frequent over Greece. Again, we had the satellite actually seeing this dust plume, which, yes, comes this time from the Sahara, also testified by the high split. Calculations, the verse true image also shows this plume crossing the Antikythera station. Calypso not only sees again this plume in the attenuated bike scatter, there at, let's say, 5 kilometers, but also what I mentioned in the beginning, clearly identifies this aerosol subtype as yellow, and yellow means dust in this 10-type categorization of Calypso. Over the Antikythera station, which hosts a LiDAR, the Pangea, the Panacea station, and in this case, now you will note that we have a very clear one-layer structure, which Tropomi typically is able to well place in height. And yes, in this case, we have a very good agreement. This is one of the issues that are already known. The satellite algorithm cannot distinguish between two layers, which of course, obviously the LiDAR can. Hot off the press and with great sadness, of course, the fires of August 2023, 3 different days, the 22nd, 23rd, and 24th here by Versuomi MPP. I'm sorry, I don't see the professor here. Nice photos of Thessaloniki sky from the Laboratory of Atmospheric Physics there at the top that were really laden with aerosols. GOMI2, I've already shown you the absorbing aerosol index, both the METOB and the METOP-C instrument you see. As was mentioned before, even the same instrument on 2 different platforms may show different results or gaps in the data. This is true, so we do our best to use all available information. And in both of these cases, on the 25th, the aerosol layer height algorithm was initialized and produced results for the validation bit. We have here the quick looks from the LiDAR in Thessaloniki at 3 different days, the thickest one there, the 23rd, and the GOMI2 estimation of where this layer was, a very clear one structure layer between 4 and 5 kilometers in height. Since I know that in the audience we have past members of the laboratory, I think they would be really maybe even sentimental to see how the AeroNet station in Thessaloniki, or CIMEL, for those days measured for the first time, as far as Professor Baez was telling me, such high values for the aerosol optical depth. I don't think this automated AeroNet plot has ever gone at 4 or even 2 on the scale of the UV AOD. To wrap it all up, because of course, yes, we are beyond in these products on the per test case. We have a long time series. We can do a more complete validation on all the different dust and smoke cases. So these are activities under ESA and EUMETSAT products. You see the various, of course, logos there. So for the GOMI2, the case of GOMI2, we have the LiDARs of the AeroNet network spread around Europe. And throughout the timeline of the GOMI2 product, we have the comparisons using various elaborate ways between space and ground. Putting those in an actual scatter plot, you see that even though we have more than 15 years of these continuous GOMI2 and some of these years multiple instruments functioning, it is not easy to, and we can discuss at the end why, to find good spatiotemporal collocations. So maybe 250 now. This graph has been updated for our EUMETSAT activities, which If we look at the mean, we see that we are in a quite good agreement, maybe almost no difference between space and ground, and a standard deviation of 2 kilometers. Moving on to tropomi, in this case, apart from the fact that we have this issue with the double layers, we have an issue so far, but hopefully this will be solved. With tropomi, when it views over land, it cannot distinguish the albedo very well, produces really not usable estimates for the height. So for this validation, we take stations, LiDAR stations that are close to the coast, so we can actually have collocations over sea. And the Californian fires I mentioned before are those really high elevated layers seen by both the satellite and the ground, and then we have a number of dust cases. Of course, we are in the Mediterranean. If you focus on the red histogram here, we have a mean difference of 500 meters, which is spectacular, and plus minus of 1 kilometer. If we include all the pixels that actually fall over land, so over land in Thessaloniki, over land in Potenza, in Granada, etc., you see that the albedo problem becomes a true problem, and the green comparisons are not indicative of the product, rather the algorithm issues. Concluding, what is the future of space-borne aerosol observations? Well, not only aerosol observations, but also quality. The future is in geostationary. Currently, and since 2020, the GEMS instrument has been in orbit. It views that part of the Asia and the Asian Peninsula there. Tempo was just launched, and we saw first light of NO2 measurements the previous month, and hopefully maybe in 2025, in the first quarter, we will have our own geostationary instrument. So these instruments will provide every hour a snapshot of what's happening over the planet, so over the location of the planet that they look into. So we will lose the global component, but we still have it from all the other polar orbiting satellites. In the team, we are involved in this Pegasus project, an ESA project, which has to do with validating these first GEMS observations, and as far as the aerosol layer height, which also is an operational product, is a true issue. We've all seen these dust storms over Asia. So in March 2021, a huge one of those covered basically the whole of China. They have all these deserts there going around the Himalayas there in the gap, bringing aerosols, you see dust across into central China, Korea, and Japan many times. So not only the GEMS, which is geostationary, but of course we use GOMI2 and tropomi to intercompare the three products and provide the GEMS people with any pointers for improving the algorithm. Of course, always taking into account any information we may have. In this case, a clear distinction by Calypso, this is the narrow swath here, the red line, a clear distinction between the dust and the smoke. Here in Indonesia, we have outgassing volcanoes, we have ash all the time, and Calypso can help us identify not only where they are, but also what type they are, and aid in the polar and the geostationary UVVs sensing instruments, their analysis. I'll just leave this at the end. All this has been possible by the development in the lab of a validation tool within the work of the PhD of now Dr. Michailidis, Kostas Michailidis, most of you know it, and the help, of course, of various ESA and EUMETSAT projects. Thank you very much.
Thank you so much, Mariliza. Questions? Vasily, yes, you have the next talk. Make a question.
Can I make a question too?
Yes.
Okay. So actually, what is, Mariliza, what is the added value beyond the fact that you bring a new information on the table with the aerosol layer hyper, but what is the added value, for example, for Stefan, if he wants to run a radiative transfer, or for Melanie, for data assimilation, because you have a geometrical property, but it's not come along with a concentration property, right? Mm-hmm. So do you see other application beyond the fact that, okay, we know where the layer lies, right?
Funny you should ask that, because what I didn't have time in the 20 minutes allocated to me is to show you an example of how how including this height information improved an assimilation and forecast system such as the CAMS ISIMWF that Melanie was showing us. On a different project, we actually had the layer of the SO2 plume coming from the volcanoes. And the system is initialized, the operational, or what used to be the operational system, is initialized placing the volcanic plume for SO2. This is a gas, but bear with me, we will move to the aerosols. So that is initialized, placing the eruption at 5 kilometers. And it was unequivocally shown by Melanie Aids, Antje Ines, our collaborator in this project, that a huge improvement to the forecast, to the comparison with autonomous space and land-based observations had, actually including the height that the Tropomi observations are able to provide. So Tropomi, apart from the SO2 load, also gives the SO2 height. So in the future, the idea is that, of course, you've worked, I'm sure, with a GRASP AOD from Tropomi. At some point, we will have an AOD from Tropomi, and we have the height of Tropomi. And when it is mature, this product, I am sure it will be, well, first we'll go through all the systems, the check systems of CAMS, and then be assimilated.
Great application.
For climate, I guess Dr. Kime is the best person to say how important it is to actually know, it rises, where does it go? It affects the neighbor. We've already seen the huge discrepancies between India and China, the emissions, but what if they mix, what if they don't? So there's a lot of applications.
Sure, Mariliza, this is great application for SO2. The ejection height, of course, it's an information that can be used for transport calculations. Yeah. However, I mean, the concentration along with the height can come from a LiDAR, But of course, you don't have LiDARs everywhere. So, I mean, the combination of passive and active sensors could help
Exactly.
a lot.
The thing is that, as Melanie was saying, the point of the forecast is that they need NRT. NRT means 3 hours. So it will take work. It's like how the Aeronet, the Aeronet community do these fast turnouts, right? Even though it's used for the validation, but maybe in the future we can see something from the LiDAR community, like a version 1.0 within 3 hours, which could be fed into an operational system. Excellent.
Okay, thank you, Mariliza. Vasilis,
join the action, join the newsletter. Follow us on social media for news and announcement.